finding the vertex of a quadratic when it's in standard form. So the warm-up, it's already in vertex form. What is the vertex of the function y equals x plus 4 squared minus 8? And so hopefully you remember that if you have a plus 4 inside the parentheses, that does shift the graph left 4 and down 8. So the vertex will be the opposite of what's in the parentheses, so negative 4. It'll be the same as the number on the outside, negative 8. So vertex form is named that because you can just look at it and you should be able to tell what the vertex is. But sometimes we have an equation in a different form, like standard form, where there's no parentheses, and you can't easily just recognize what the vertex is. So our goal today is to take a look at how you find the vertex when it's in standard form. So part 1, it says finding the vertex of a quadratic. Methods for finding the vertex. You could graph it. Again, the vertex is where it changes direction. So if it's a smiley face graph, the vertex will be a minimum. If it's a frowny face graph, the vertex will be the maximum. You could just type your equation into Desmos or graphing calculator and find the vertex that way. That's probably the quickest way to do it. The second way is remembering how it shifts from the parent function. So if it's in vertex form, another quick way, just knowing it's the opposite of what's in the parentheses and it's the same as the outside. And our new method, which we'll take a look at when it's in standard form, how do you find the vertex? So first review, let's consider the quadratic function f of x equals x squared minus 4x minus 5. You should be able to identify a, b, and c. So this again is when 0 is on one side. You look at the number in front of the x squared, and that is your a value. So here the a value is 1. The b value is the number next to the x, negative 4. And the c value is the number by itself, so negative 5. All right, we've been practicing quadratic formula for a few days, so using that formula, we plug in. Remember, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And remember, I want you guys calculating these three pieces right here, which they did right here. And then from here, we plug it into our calculator and we get the two x-intercepts. But let's simplify a little bit further. So we know that the square root of 36 is 6. And if we solve that, you can either do the whole top thing first, like 4 plus 6 divided by 2, or you can break it up into 4 divided by 2 plus or minus 6 over 2. So what that gives us is the 2 plus or minus the 3 to get our two answers. So again, we've been just typing it in our calculator, but we can break it up, and this does turn into 2 plus or minus 3. So we'll need that to figure out this next part, which is, all right, what does that have to do with the vertex? So it says, how can you use the 2 and the plus or minus 3 to get the zeros? How can we easily get the 2 in the first place? So those are questions to think about. So here is a graph. We can see the answers. The two answers are negative 1 and positive 5. Those are the x-intercepts of the graph. And the vertex, so now we're looking at the vertex. This will be the minimum value, is 2, negative 9. Now there's a few pieces that we're looking at here. Number 1 is the line of symmetry. The line of symmetry is the mirror line. Where can you fold it in half so that it would match up onto itself? So here, line of symmetry is y equals 2, because all along this line, the y value is 2 right there. Actually, not y equals 2, it's x equals 2. So x equals 2 because any point on this line, the x value is 2. So that's the line of symmetry. The vertex is the 2 for the x value, and then the minus 9 for the y value. So the question is, how can you get the value of negative 9? How can you get the value of 2? And solve. So if you take a look at our answers right here, the negative 1 and the 5, the x-intercepts, we start at this 2, and if you do 2 plus 3, you get the 5. If we do 2 minus 3, we get the negative 1. So where does that come from? And again, it comes from quadratic formula. So when we split it up, we had that 2 right there, and then to get the x-intercepts, we added 3 to get the 5. We subtracted 3 to get the negative 1. So those are the x-intercepts. But the vertex itself was actually this number. The x value was this number right here. That 2 was the x value of the vertex. Remember, the vertex is 2, negative 9. So here, the 2 comes from that first number before we add or subtract the second number to find the x-intercepts. So how do we get that? Well, if we go backwards, that was this number right here divided by this number. And if you remember what that was your opposite b divided by 2a. And so that leads us to one way to find the vertex, and that is you need the x value. It's just opposite b over 2a. That will give you the line of symmetry, 2, and also it's the x value of the vertex because it's right in the middle. Before we added 3 or subtracted 3, we got that middle number, x is 2. So then the question is, all right, we have the x value. How do we figure out the -9 just from the equation if we weren't to graph it? Well, if you know x is 2, we can plug in. So again, to find x, we just do opposite b over 2a. In this case, the b value was -4 and the a value was 1. So it was opposite of -4 over 2 times 1, which gave us the 2. To get the y value, you're just going to plug in. Remember, we have this function f of x equals x squared minus 4x minus 5. So to find the y value, f of x is the same as y equals. We're going to plug in where x is 2. So all we do is just plug in a 2 everywhere we see the x. So again, I'll highlight kind of where we plugged in. So we replaced all the x's, or the parentheses with the 2. And then you can just type that in your calculator, or you can do it in your head. So we would have 2 squared minus 4 times 2 minus 5. And again, you can just type that in as is. Oh, I close my calculator. Same with like when we typed in the discriminant, you just type it in as is and get your answer. My calculator's taking a second to pop up, so I'll just wait, I guess. There we go. Okay, so if I just, I'll just do it on Scratchpad. So we'll just type it in, just like I said, as is. So it was 2 squared minus 4 times 2 minus 5. So when you plug in, the x value is 2, the y value is -9, and that gives us the vertex. F of 2 equals -9. And there is our vertex. X is 2, y is -9. That would be the lowest point in this graph because it is a smiley face graph. It is the minimum. And that's it. So the summary, to find the vertex, you put the quadratic in standard form. So get everything on one side and identify what is A, what is B, what is C. Find the x value by doing opposite b over 2a. When you find x, you plug it into the original function and solve for y. So let's do a few examples, and then your assignment will be 1 page to practice. So number 1, find the vertex of the parabola given this equation. F of x equals x squared minus 4x plus 7 is the vertex of min or max. How do you know? Okay, so first step is identify A, B, and C. Whoopsies. All right, A is 1, B is -4, C is 7. All right, next step, so step 1. Step 2 is plug into opposite B over 2A. The opposite of -4 is +4 over 2 times 1. So 4 divided by 2 is 2. So there's the x value. The third step is plug it in to the original function. So f of 2 equals 2 squared minus 4 times 2 plus 7. Then you can just type this into your calculator, or you can do it in your head, and get the answer. All right, so let's type it in. So we'll have 2 squared minus 4 times 2 plus 7, and this will give us the y value when the x value is 2, and that is 3. So if we were to graph this, this graph would change direction. So here's the vertex at 2, 3, and it says, would it be a minimum or a maximum? So look at the a value, which is 1, and positive. So our graph is smiling, which means that this vertex, where it changes direction, would be a minimum. Okay, and that's what we're doing today. Number 2, find the vertex of the parabola. Given this equation, is it a min or max? Okay, so same thing. A equals -2, B equals -12, C equals -23. The next step is find the x value, which is opposite B, which is 12, over 2A. So that will be 12 divided by -4, which is -3. So there's the x value. The last step is to find the y value. So we're going to plug in a negative 3 everywhere we see an x in the standard form equation. All right, so again, notice I just plugged in a negative 3 everywhere we saw the x, and we're just going to type in this side of the equation. So let's go ahead and do that. So we have 2 times negative 3 if you square it. And it was minus 12 times negative 3 this time, and then minus 23. Okay, so when the input is negative 3, the output is 31. So if we were to graph this, our vertex, let's get a highlighter here. So let's write f of negative 3 equals 31. Okay, let's change colors. So the vertex would be negative 3, 31. And would that be a min or max? Take a look at the a value, it's negative. So we have a frowny face graph, which means that that vertex would be a maximum. Okay, and one last problem here. It says find the vertex of the parabola given this equation. Is there a min or max? How do you know? Okay, so again, first step, find A, B, and C. A is negative 3. B is 24. C is 48. Next step, x equals opposite b over 2a. The opposite of 24 is negative 24 over 2 times negative 3, which is negative 24 over negative 6, which is 4. So there's the x value of the vertex. Now we're going to plug it into the original function. Our input is 4. So what's the output? What's the y value? We're going to plug in a 4 everywhere we see the x. So again, we plug it in, and then we can just type this into our calculator and get the output. So let's go ahead and do that. So we'll have a negative 3 times 4 squared plus 24 times 4 plus 48. All right, so the output's 96. So when our input is 4, our output is 96. So the vertex, let's change direction or change colors here. Vertex is 496, and it would be, this is a frowny face graph, so it would be a maximum. All right, your assignment is just to practice the vertex form today, and then we'll put it into context in the following days. You have these quadratic equations. Find opposite b over 2a, plug in, find the y value. You have a word problem application. It's the same as all the other ones. There's just words to it, so see if you can solve that. And that's it. We'll go over any questions that you have in class tomorrow.